In this video, we will continue from where we ended. We are simply saying as costs rise, the quantity extracted will fall over time. And as quantity extracted falls over time, it will get to a point where it will fall to zero. This is the point where the total marginal cost reaches the maximum willingness to pay. In other words, if the maximum the market is willing to pay is, let's say, $100, and your cost gets to $100, that is a point known as the choke point, because any extra unit extracted from that point will just make your cost to become higher than the price you are receiving, or higher than what the market is willing to pay. That is known as the choke price. That's the choke price. So for the resource, the demand will simply fall to zero at that point, because no one is willing to pay any price higher than that choke point. So here, for example, this will be your choke point. This will be the choke point because no one is willing to pay anything higher than that. Now let's take a look at another case. This one, the previous one, we had said that there is no transition, so things will collapse and it will fall to zero. We want to look at a case where you can transition to a renewable substitute. Now, here we are saying an efficient allocation implies a smooth transition to exhaustion and or to a renewable substitute. So if you are managing the resource, you really want to be able to smoothly transition to a renewable substitute. Now, the transition point to the renewable substitute is called the switch point. Now, it's important to note that this switch point will occur only when the total marginal cost of the depletable resource equals the marginal cost of the substitute. So if, for example, it costs, let's say to generate green energy costs $60, but to generate energy using oil costs $20, there will never be a transition. The transition will only occur when extracting oil, when the cost keeps going up until it reaches the cost of that green energy, let's say 60-60, then there will be a switch. So this is what this chart is trying to show. So A is looking at constant marginal extraction costs with substitute, and B is looking at constant marginal extraction costs with substitute. The first chart we had seen was without substitute. Here we are looking at the case with substitute. So over time, you can see that it's going on. The other diagram, by the time it went to 9, we had hit the choke point. However, what happens is, with time, we can see that, yes, the extraction cost is constant, but the total marginal cost is increasing. Why? Because of increasing relative scarcity. Until you get to a point where the total marginal cost of extraction reaches, as we had earlier mentioned here, that the total marginal cost of the depletable resource equals the marginal cost of the substitute. At this point, it reaches the marginal cost, or the cost of producing one extra unit of the renewable energy. Then there will be a switch that will occur here. This will be your transition point or your switch point. You will switch from the depletable to the renewable at that point. It's important to remember the point where your switch occurs is the point where the total marginal cost of the depletable resource equals the marginal cost of the substitute. If the total marginal cost of the depletable is less than the marginal cost of the substitute, there will never be that switch. But when they become equal, there will be a switch, because no one wants to keep producing the depletable when the cost has become higher than that of the renewable. The market will automatically, the producers will switch. Now, let's look at a case where there is a transition between two depletables. I think this title has a typo somewhere. This should be a transition to a depletable substitute. Okay, please adjust this. This is a transition to a depletable substitute. So the transition for two depletables with different marginal cost will also be a smooth one. Without wasting time explaining this, you can see it in this curve. Let's call this depletable 1 and this is depletable 2. They are all depletable resources. You can see that the total marginal cost of this one is lower than this. So you will, of course, continue producing this one. However, when you get to the point where the two total marginal costs are equal, you will switch. You will switch from the one that is getting higher to the one that is lower. In this case, a switch will occur. That's all what it's trying to do. Now, we want to look at the next case. The first one was constant marginal cost without any substitute. The second case we saw was constant marginal cost with a renewable substitute. The third case was constant marginal cost, but you were switching between two depletables. Now we are looking at increasing, the fourth one, we are looking at increasing marginal extraction cost. And this is the reality for most resources. Why is it the reality for most resources? Because when we start extracting, you always go for the lowest hanging fruit before continuing to the higher ones. So in this case, we are looking at increasing marginal extraction costs. We are saying for this case, the marginal user cost declines over time and reaches zero at the transition point. The resource reserve is not exhausted. The marginal cost of exploration can be expected to rise over time, blah, blah, blah. Let's take a look at the chart. It helps us better understand. So the first chart, which is A, is looking at increasing marginal extraction costs with substitute resource, and B, increasing marginal extraction cost with substitute resource. One is the quantity profile, the other one is the marginal cost profile. So here you are looking at the quantity. You can see that the quantity extracted is decreasing until you get to a point where you have to switch from that depletable resource to another one. Now, the challenge you have is that in this case, you no more have, of course, the total marginal cost is increasing, but it's increasing at the faster rate. Why? Because you no more have your constant marginal extraction cost. Now you have an increasing marginal extraction cost. Generally, this happens when you throw in the cost of externality. If you ask the firms to consider their externality for every unit produced, then you will find that you will no more have that constant marginal extraction cost. It will start rising. So it's a good idea to ask firms to internalize any externalities. But that's not what we are trying to show here. We are just trying to show that at times this is what happens. And when it happens, there will be a change. Okay? Now, one of the things that will affect how fast this switch point will occur has to do with technology, because with technological innovation, it can keep this cost lower for a long time. That's what we are trying to say here. Exploration and technological progress. So if you have technological progress, it's going to reduce extraction cost. And at times with exploration, you can find reserves which are pretty cheap to extract that will also push the transition point further into future. That's just what we are saying here. Remember, all what we are doing is we are looking at efficient intertemporal allocations, how to efficiently allocate resources between now and future generations, taking into account different costs. Now, one of the things that help the proper management of resources is appropriate property right structures. So when we talk of property rights, it's really assigning ownership to someone, and for that to work, the property right has to be exclusive. So for example, my phone is exclusive to me. It's universal. Wherever I go, it's my phone. It's transferable. The right, I can transfer it. I can sell my phone to someone and I can enforce it. The laws are on my side for that. A resource governed by well-defined property rights structure will then have both a use value, so I can use it as I choose, and of course I will make the best use of it because it's mine, and an asset value. An asset value in the sense that it serves as an asset. It has value to you, you can sell it. Now let's take the case where we are taking into account externalities. So here we want to put in external environmental cost in the whole mix of what we've been talking about. The inclusion of environmental costs will result in higher prices. So extraction costs, of course, will go higher. The total marginal costs will go higher, and of course as a result of that, the transition point will be faster. It has a demand effect and a supply effect. What do we mean by it will dampen demand? When prices go higher, people buy less. That's the law of demand. Quantity demanded decreases as prices rise. It also has a supply side effect in the sense that when the prices or when the cost of production rises pretty fast, it's going to cause the transition point to occur sooner. It means suppliers will, or an economy will transition faster from the depletion, from the depletable resource to the renewable resource. So which effect dominates depends on the shape of the marginal extraction cost. When we talk of which effect, it's really which of these two effects. So the concept of external environmental cost ties together the fields of environmental economics and natural resource economics, because in environmental economics, we absolutely want the managers of natural resources to take into account those costs, the externalities. So here we have some charts. You can see that here we have higher quantities which are extracted. This is your quantity extracted chart. Here at this point, let's say period 1, you have 7, but when you force them to internalize external cost, at period 1 they extract a lower quantity. The quantities they extract is relatively lower compared to without taking into account externalities, and you can see that the cost of extraction is much higher at period 1 than without, which means you reach your transition point faster. This is the case of transition point. If we had no transition to a renewable, then the choke point would have been reached much faster when you take that into account. However, the idea is not just to crash things, but it's to transition much faster into a renewable. And you can see we are looking at a renewable here. That's why you have things staying there. Think of hydroelectricity, for example. Yes, there's a cost of extraction, but if we are using it at the right rate, then there is no increasing scarcity to cause the total marginal cost to be increasing. You have the straight line. And that is it for this lecture. Have fun, and I'll see you in class.